All right, we're going to look at counting atoms. Let's review what a chemical formula is. We have two chemical formulas here. We have CO2, right here, and we have aluminum, I believe it's sulfate, over here. So these are chemical formulas. They are made up of letters and numbers. So if I am going to look at this first one, carbon dioxide, here it says what elements are present in this compound. So I'm going to write over here capital C. If you do not know that that's carbon, look on your periodic table. Remember, the file for the periodic table is in the previous module, atomic structure. So we have carbon. And we have another capital letter, oxygen. So I'm going to write oxygen. Remember that symbols can also have lowercase letters in them. So if I come over here and I'm just going to name these elements that are present, Al is together, that's aluminum. S is just a single capital letter, that is sulfur. O is a capital, that is oxygen. All right, let's go back over here to carbon. Carbon, or carbon dioxide, it says how many atoms of each element are present. Atoms of each element. Well, I'm going to look at subscripts. So we use the element symbols, that tells you the element, and then there's going to be a subscript, which means below. So these little numbers below are subscripts. So that right there is a subscript. The subscript is going to tell us the quantity or the number of atoms of a specific element. Notice that carbon does not have a subscript. We do not use 1. We do not write the number 1. The symbol represents 1 atom. So there's no need to put a 1 there. So there is 1 atom of carbon. There is a 2 out beside oxygen. So that means there are 2 atoms of oxygen. This compound has a total of 3 atoms. Let's look at this other one here. Aluminum. Aluminum is how many atoms is there in aluminum? There is a 2, so there are 2. Now, let's look at SO4. SO4 is a compound by itself. We call it a polyatomic ion. We'll learn about it. It is made up of 2 elements. And notice it's inside parentheses. The parentheses tells me how many of those SO4s we have. So I have a 3 here. So that means I have 3 SO4s. Oops, my 4 is right there. All right, so I can do this one of 2 ways. I can write it out like I did here, and I have 1, 2, 3 S's. Well, for oxygen, I have 3 O4s, so that is 3 times 4, which equals 12. So I have 12 oxygen. So if you're a visual person, you may want to write those out like that. If you are not a visual person and you're more mathematically inclined, you understand that this is the distributive property. I will take the 3, distribute it to the S. So 3 times 1 is 1, or 3, so I get 3. 3 times 4 is 12, so I get 12 here. I don't care which way you use it. That is what you are you just need the total. You can write it out or you can do it mathematically here. So, what is the rule when there is a number outside the parentheses? You're going to have to multiply. You're going to have to distribute that number to what's inside. So, multiply by distributing or distribution, just like your distribution property. All right, we're going to do some of these as examples here. So let's start off here. You don't have to write the names of the atoms. You're just counting. So for this first one, you have Na to begin with, a capital and a lowercase letter. So Na, there's no number, so we know it's 1. All right, we have Cl. The L, that is an L, not a capital I. Cl, there is 1. All right, let's look at the next one. N4. So there are 4 N's. N is nitrogen. Oxygen has a 10 by it. So the O10, there are 10 atoms of oxygen. Now, if the directions had asked you for a total, then you would, for number 2, the total atoms in this compound would be 14, but it's not asking for the total, just asking you to count. So, Cl2. Cl, there are 2. Again, we're going to go to oxygen. There, O, there's no number. That means 1. All right, Na. Oops, doesn't look very much like it. Na means, then you have Br, bromine, no number, 1. Number 5 is going to be like our second example. It has parentheses. So I know that Al has 1. And then I notice outside the parentheses, I have a 3. So whatever's in the parentheses, there are 3 of them. So I can come over here and do OH, OH, OH. And that means that I am going to have 3 O's. So I can put O is 3. And it means that I also have 3 hydrogens. H is 3. Remember, you can use the distributive property if you would prefer. You could say 3 times 1 is 3. 3 times 1 is 3. I'm going to skip number 6 because I want to do a couple more at the parentheses. Number 14, we have Ca, no number, so it's 1. Again, we have OH in the parentheses, but there's a 2 out there, so I just have 2 of them. So that means for my O's, I have 2. And for my H's, I have 2. Again, you could distribute it. 2 times 1 is 2. 2 times 1 is 2. All right, let's do the number 15, magnesium. Notice there's a 3 with it, so Mg is 3. Then I have PO4 together, and it's 2 times. So my P's are easy. There are 2 of them. So I'm going to put P equals 2. And look at my oxygens, though. Each oxygen has a 4. So I have 2 of them. So 2 times 4 equals 8. So oxygen equals 8. So if I go over here, remember you could have distributed. 2 times 1 is 2. 2 times 4 is 4. All right, that leaves number 6, 16, 17, 18, and 19. If you do those on your own and submit them as extra credit, or if you submit them, I will give you extra credit. I'll put a specific assignment after this video that says extra credit. So to do that, I would work them on paper. I will put a text box, and what I wrote, the symbol equals and the number is what you would type in for number 6, 16, 17, 18, and 19. So if you want extra credit, you would do these. Some of you need the extra credit. If you have any questions, remember, send me an email. We'll set up a Google Meet, and I can try to talk you through it.